I'll start today's seminar. This is the 466th seminar of Ocean. Oh, more than 10 years we had this seminar. Okay, title of the paper of today, Mapping Marine Debris Risk Using Expert Elicitation, Empirical Data and Spatial Modeling. It's from Australia. The author is Jordan Gacutan and others. And the paper, please. The abstract of this paper, I read through this abstract because you can understand the largely of this paper through this abstract. Anthropogenic debris is a widespread and prevalent component of aquatic systems. Organisms are increasing exposed to debris, leading to detrimental impacts through pathways such as entanglement, ingestion, and bioaccumulation. Multiple taxa interact with the debris, and while the consequences to individual organisms are known in principle, their impacts at scales relevant to management are poorly understood. Despite uncertainties, decision makers are tasking with addressing issues associated with debris and require an estimate of risks. Here, we provide a methodology to estimate risk posed by specific debris items to a range of organisms within a management area. Risk was determined as a function of both first, the consequence of an interaction, and second, the likelihood of exposure, estimated through expert elicitation and the empirical debris data, respectively. Using the New South Wales NSW Marine Estate as a case study, the methodology identified specific debris items posing risks to 7 biological assets. That is, they are benthic assemblages, cetaceans, fish and sharks, planktonic assemblages, shoalballs, seabirds, and turtles, through several pathways. Items posing high risk to these biological groups included fishing-related items such as fishing line, net, trap, and path, through pathways of ingestion and entanglement. Microplastics and hard plastic fragments also pose high risk via ingestion and bioaccumulation. The values were then assessed spatially using marine debris database, identifying variability in risk across the marine estate and thus priority areas for management. By identifying the prominent debris items causing risks to specific and multiple assets, resources may be better allocated to maximize the efficacy of interventions. This paper, not so long, but a little hard to follow because it has many supplementary materials. So if you read all of the materials, supplementary materials, it is easy to follow, but only with the paper, maybe a little difficult. So I made this diagram, and to understand this paper, you have to understand the pathway. Pathway means some causing risk action, like ingestion, smothering, or entanglement, like that. And asset means some animals or habitats like cetaceans, fish, birds, benthic assemblages like a coral reef, something like that. That's the asset. And I told you asset and pathway. That's very important term. And debris items, you know very well that thing. And the spatial boundary is NSW, New South Wales of Australia. And as the title mentioned, mapping marine debris risk. They focused on the mapping and make maps about marine debris risks using several instruments. So I made a diagram for this paper. They assess the strengths of interaction. Interaction means debris and asset through a pathway and exposure. Through these two tools, they determined risk, especially spatial risk in an SW area. And using this risk, assess the risk value. This process, the strengths of interaction was assessed through expert elicitation and exposure. They used for exposure assessment, they used debris data and distribution, especially spatial distribution of each item. And through this tool, they assess risk. They did risk determination and assessing the risk value, especially in the NSW region using modern debris database. It means through this exposure data with the debris. And through this process, they identified variability in risk in spatial. And after this process, they identified priority areas for management. Because the resources is limited, we have to use these resources very wisely. So allocating resources to maximize the efficacy of the intervention of the government or local government. That's the main process of this paper. And next, we see the papers. We have 5 supplementary materials and it's kind of long. So I think if I mention this, explain the supplementary material, it's important, but I think I'm run out of time. So I mainly focus on the paper. I look through the figure and tables first. I go to the figure this. I told you again, but figure 1 and figure 3, maybe 2 is very important. If you understand and read carefully, you can understand most of this paper process, research process. First, they assess the strengths of interaction. And through expert elicitation, they gathered expert and they had distributed survey through online and gathered answers from them. And 41% of the surveyors answered. And through the process, they gathered expert elicitation for consequence and likely of the consequences. For this terminology, table 1, they explained for all important terms. Through this consequence and the likely of the consequence, they measure the strengths of interaction. This is for webinar and meeting, online meeting, and they assessed the exposure to the debris item. They used empirical debris database. In Australia, for many years, they monitored debris. So they used the debris data. And they standardized the debris per item per meter because they adopted, they used 3 databases, KLIS and AMDI and Sea Shepherd data. So they have to standardize because the method is different. The methods are different for each research. And data abundance per grid. This paper, they mentioned the modeling. Modeling means data abundance per grid. They assessed for spatial density of the data, the debris. they modeled some model prediction, the density for the grid, because the data is per item per meter. It's like linear density. So they used the model to get area data, and they use the presence and absence of the asset. Asset means, I emphasize the asset term, is a fish, shark, or cetacean, or turtle. That's the asset. Because the risk assessment, for the risk assessment is a very important term, like this. If you have very hazardous material, even it's a small amount, if it is besides you, it's very toxic. It could be very toxic, but a large amount of toxic material, it is the, I'm sorry, but it's polar area or Antarctic area, it's not toxic to me at all. That's the risk assessment is very important. So we have to assess, we have to know the distribution of the asset. Fish is there or not, and the debris is there or not, with fish or turtle or cetacean, like that. So they assessed, they used the knowledge of the distribution of the asset. So presence, absence of asset, it means that. And together with the strength of interaction and exposure, they assessed risk estimates. That's the process of the research of them. And terminology and definitions adopted in this paper: biological asset like cetaceans, seabirds, and turtles, and debris item, you know very well, microplastics, straw, plastic bag, or fishing net and fishing pot trap, and pathway. I told you it's very important term: entanglement, ingestion, and bioaccumulation. Consequence. Consequence means if the animal get entangled in fishing net, what is the consequence? Starvation or death or retardation of growth? That's the consequence. And the likelihood of consequence, then the fishing net can entangle the animal, but is likely to happen to the animal, to turtle or to fish, is the likely of the consequence. And the strength of interaction is combination of consequence and the likely of the consequence. Then consequence means a theoretical term, like a theoretical term. The likelihood is the actual in reality. That's the likelihood of the consequence. The exposure is the debris should be there to be exposed to the asset of the asset to the debris item. That means exposure. In the risk, I told you risk assessment, how dangerous the item is, like the risk. Is the risk. And it's very important figure. We 7 assets. You can see 7 assets or what they are, like cetacean, benthic, assemblage, fishy, turtle, like that. And we have an example of dolphin, maybe whale, dolphin. Dolphin is here. Pathway, they defined 9 stressors: entanglement, ingestion, smothering, and bioaccumulation, like that. And this dolphin can be entangled and encounter the debris item. All item is not dangerous to the dolphins, but like net, fishing net can be very dangerous. So they have to consider debris item, encounter the debris item, straw, bottle, or what is plastic bag, and several items. They have to assess the consequence likelihood through expert survey equals expert elicitation, and all all items. They did this kind of research, and this SOI means strength of interaction for each pathway. For each pathway, they assess strength of interaction, and for ingestion, for pathway 1, 2, 3, 4, up to 9. They assess this kind of process. It's called the theoretical framework for assessing debris risk through expert elicitation. It's just the strength of interaction. We have another process. Another process is exposure to debris item. They use the database. So, and next one is the map of New South Wales. In this paper, they mentioned the 3 nautical miles. 3 nautical miles, just 5,500 meters. So I think the paper was long. I measured this length in Google is more than 1,000 kilometers. So the boundary should be here. This is because the NSW Marine Estate is orange color. Start here to here to there is more than 1,000 kilometers. And this area, and this is boundary. And they divided NSW into 3 regions, north, central, and south, because some assets are here, but not there. And some debris are here, not there. So they have to divide the area. And in table 2, strength of interaction, they rank result using this rule. All assets were considered of equal value. Fish or station have equal value. And if for pathway or item post a high risk to one or more asset, and the pathway or item was ranked as high risk over. High risk to 1 or more, then it's high. Likewise, pathway or item post moderate, 1 to 1 or more asset is moderate. Resulting risk of strength of interaction, length moderate. Likewise, low and low to 1 or more, low, and a similar way. And risk for debris item is about debris item. More than 20 of grid cell with the data were categorized as a high risk for a debris item. Each item is considered high risk. More than 20% and 25% were categorized as moderate or high. Then resulting risk was moderate, and more than 30% of grid cell categorized as low. Then result was low, and 40% as low. Then minimal. And they used through shoreline beach debris data. One is KLIS, key reader item survey data, and they have data range, habitats, estuary, and how many sites and how many transect. This survey used the transect method, and Australian Marine Debris Initiative is started 2004, but they used 2008 to 2020, and they have a lot of events. It's cleanup events, and the site is 617, and it's organized by Tongaroa Blue Foundation, and the Sea Shepherd Australia, and East Coast also, and 61 events and 42 sites. And this is the subtidal data. Divers searched the debris underwater. So site is 112 and transect 70. And this cleanup data, AMDI and 3 shepherd data is from cleanup. And this is KRIS data is transit data. And the item came from AMDI. They adopted the item category and they chose the 40 item for AMDI survey method. And they assessed the level of spatial risk for north, central, and the south of NSW area. And this is risk value for expert elicitation, and they considered debris abundance because they have to consider the exposure. Then they can they divided this debris abundance minimal, low, moderate, and high in the risk value minimal, low, moderate, high. Then metrics of using metrics of this table, they can assess the spatial risk, like debris item abundance is high if the debris are there, so much debris are there, and risk value is high, then the area was ranked high. I mean, the risk is high to that debris item. They did this table for each debris. And let's see table 5. Table 5 is value of strength of interaction. They didn't consider the exposure. This table is for strength of interaction per asset by each debris item. You can understand to see this microplastics, plastic rope, something like that. And this is the 7 assets. And basic assemblages, cetacean, fish and sharks, plankton, seabirds, shorebirds, and turtle. And for cetaceans, 6 debris item post high risk, like a plastic rope, hard plastic fragment, plastic bag, and fishing net, fishing trap, and pot and bulb, drinking package. And for turtles, 5 items pose high risk. And when I read through this paper and supplementary, it's different from our situation. For example, I thought fishing net pose high risk for basic assemblage, like smothering to the coral reef, but they don't think fishing net cause smothering to that area because they didn't observe smothering because of the net, something like that. I mean, in this paper, it's related to the NSW area and their knowledge. So, but we can adapt this method to our country. I think it's actually this paper was very interesting to me because we can adapt this kind of method in Korea to Korea situation later, next year or next year. Yeah, this year maybe. Yeah. It's a very good tool, I think, and we can benchmark this methodology. And it's the example of the spatial risk assessment for cetaceans and turtles and for each debris item. And if you see this region, you can understand easily. High is red color, and no debris data is gray, and outside the habitats, this is white color like that. And usually in central or south area ranked high risk for cetacean and turtles. And spatial risk for selected debris item across all 7 assets. They considered 7 assets together with the asset together, and then they produced this map. And per balloons, central area ranked high. This area has high risk for balloons and food web and plastic bags and traps and pots and fishing line. South area has high risk. And compared to each other of this debris item, balloons are dangerous to this area. I think they have a lot of balloons on the coast. In our country, I'm a little surprised because in our country on the coast, we don't have a balloon so much. I seldom found the balloon, but here I read another report or paper, maybe a report, Australian balloon, some initiative or something like that. So we don't have that. We don't have a lot of balloon in our country, but I think they have a lot of balloon there. And they made a risk per debris item per management zone. It's the final decision. They did this research. How urgent? What is the priority of the management for the debris, for the asset, for debris item, asset, and pathway? They have to consider pathway, asset, and what is the item? So together with the data and expert knowledge, they produce this paper to allocate their resources, human resources and money, capital resources. So they made this table. Is the final important finding of this paper. So this row, this column doesn't consider debris abundance, just the strength of interaction. And this is for NSW region. And they divided 3 regions. These 3 columns is for each region, north, central, and south. So strengths of interaction are high for balloons, fishing line, fishing traps and pots, and hard plastic remnant, plastic bag, and fishing rope, soft plastic remnant, and microplastics. And for each region, to north region, hard plastic and plastic rope and microplastics ranked high, and central balloon, fishing trap and pot, and plastic bag, soft plastic remnant, microplastics. To south area, balloons, fishing line, and plastic rope and microplastics pose high risk. I think it's the last table, and I don't have more figures. Okay. And spatial data available for microplastics. And used it's already 11:09, so I don't look at this paper in detail because the figure and table explains almost all of the contents.
And how about check the supplementary data?
Okay, supplementary data.
Just
what is the first first one? This one?
Yeah.
Yeah, the supplementary material one is definition used in this paper. Yeah. This is the risk assessment matrix adapted from NSW Marine Estate. debris problem is serious in this region. They organized some working group. It's called some working group. Some working group. So I thought the debris problem is very serious in this region. So they researched debris and risk assessment throughout the years. So I told you already, likelihood, almost certain, likely, possible, unlikely, rare. Then they can add a level of risk. You can understand just to see this table, and it's the metrics and cross this one and this one, they can get this consequence level, insignificant and minor. And if you cross this level of risk is high and the almost certain means is surely happens, then the consequence level is major, and this level is catastrophic, like that. I think you can understand. Cross check after cross checking this table. And definition. I'll skip this because very easy term: benefit, impact, threat, and this is the pathway entanglement. It's 9 pathway. Just to see these terms, okay. And consequence, we have to rank what is insignificant and catastrophic. So 1, 2, 3, 4, 5. 5 levels. They have insignificant, minor, moderate, major, and catastrophic. Likelihood also, rare, unlikely, possible, likely, almost certain. They suggested the percentage, how often, how the consequence happens, and confidence, because it's the expert opinion. So expert should say, I'm confident what I said. I'm not confident. I'm not sure, like that. Because they don't have all area of information, because expert belongs to one area or one and more, but not all area, I mean.
And they don't have quantified evidence of their opinion.
Yeah.
Just a guess.
Yeah. And definition of debris we know very well. Okay. What is second? Third? This one?
Third is okay.
Third is okay, maybe. But this is two. Second. No. Second. Okay. I don't have time. So if you understand this paper very well, please refer the supplementary. Supplementary is very good and in detail, so we can follow the step easily, the step of this research easily. This supplementary materials are very important to understand this paper. And data resources, manipulation, surveys. What is the survey site for debris data? I told you AMDI is a long history, and KLIS is new to me. Anyway, they did, and subtitle data, they published a paper in 2014. So I saw this paper. You can refer this paper to understand the subtitle data. And Sea Shepherd is famous, right? International debris NGO, maybe.
Marine conservation.
Yeah. Okay, description of and data sources for spatial file, and this is survey site for coastal area, and the subtidal area C. Yeah. AMDI data, much more than others. And this is debris abundance. This is they called modeling. They used K means clustering. Then you can understand that this central or south area have high abundance. And this is for each item. So they have many information in this supplementary. Number of sites, we can understand by year and by region. That's all. And number 4, key pathway. Key pathway today, George, this is key pathway. If identified more than 50% of expert responses. And item identified with the strength of interaction estimated as high, and items are presented in a particular order. Key item, key pathway in the spatial risk. And for each region, for each item, they made this kind of spatial risk. So based on this assessment, they made across the asset spatial risk. Across the asset means together with the 7 assets. They made risk map, but for risk map, they made each item for each region. Just for asset, they made together with the all asset, they made risk map. In the supplementary 5, they suggested all information about this. Information. Last one, this one. Yeah. This is the 11 item for across the asset, and for each item for each asset. So like this. Yes, I think it's a huge job. It takes a long time and a lot of works. They devoted, I think they devoted much of time, their time to this research.
Very detailed,
very detailed
results.
So it's very good to benchmark this.
I wonder how much the budget was doing all this work. It's very thorough. It's quite a lot of reading.
Yeah, it's a lot of reading. Paper
Yeah.
is not long, but
Yeah.
to understand
Junsu,
Mhm.
is there anything mentioned about the subtitle in terms of average depth?
I don't think so.
I see, yeah, because it's subtitle as being discussed here, which means
They mentioned
the citations, for example, as one of the items, one of the groupings they included here. The
They
assemblages, the
refer-
corals may be easy because it's near shore.
Mhm.
At a relatively diable depth, like what we do in Cavite,
Mhm.
along the shores of Ternate, which is
Mm.
in my target site. So our monthly underwater survey and cleanup is gives us a good idea. But going to all the coastline of Cavite is quite, if I do this, it will be good at least. 1 year relevant, 1 year data gathering would be very relevant in terms of the accumulation, bioaccumulation.
Mhm.
So again, maybe it's the discretion of the surveyors, right? In terms of the subtitle sites, especially for what they did on benthic assemblages, the coral reefs, as well as the cetaceans and other areas, other groupings. Thank you.
Thank you for your opinion. And they didn't explain about the physical situation, physical characteristics of the NSW, but I think they know very well about the physical oceanic characteristics of the area and how the stations are there and near shore or marine environment. Marine environment means offshore, and what debris are there like that. And if, as mentioned before, if they don't have information, they used their knowledge. In the paper, they mentioned they used knowledge. So as explained in the abstract, fishing-related item and what is microplastics and the hard plastic fragment pose a high risk via ingestion and bioaccumulation and ingestion and entanglement. In this paper, they mentioned ingestion and entanglement pose high risk, and the item are fishing related and microplastics and hard plastic fragment. They said about the items and pathways and assets more in detail in the paper and supplementary material. Please refer. Thank you. That is the all of my presentation. And if you have any questions and opinions, let's tell them. Okay, floor is yours. And any questions, please.
So you will be sending us again this paper, right? So we can.
I sent already.
You sent already. Okay.
By
Thank you.
email.
Yeah.
Okay.
So we can read more thoroughly and how the methodology was, as well as maybe I can communicate with the guys. If it's possible to do it here, why not? Very thorough.
We have
course.
many. I'm sorry.
Yeah.
Yeah. We have many debris data and pathway data like entanglement or
Yes.
ingestion, something like that. But this kind of research is new, but relatively new. I mean, we can think about this kind of risk assessment, but the fact we didn't. So, I was interested in this paper. Any opinions?
Actually, in Korea, there are two R&D projects in KIOST, in Korea, in KIOST and in KEI. They are doing this kind of risk assessment on marine ecosystem and marine debris. So maybe they will follow this kind of methodology for risk assessment. So I think we can have some seminar or we can have a chance to share the information with that group.
And I think as for my knowledge, Korea studied floating macro debris survey. For this research, I think we need floating debris data, especially for large animals. We will start floating debris, macro floating debris research and marine, what is called asset research. So if you have any program like this in your country, could you tell us?
And any other comment or question about the
I have.
paper?
Hi,
Jason.
this is Jason. Yes, I have. Thank you for sharing this very interesting paper to us. Thank you, Jong-soo. And I have one question about the questionnaire to the expert, like the animal expert, like the cetaceans or fish and sharks, those or turtles, because all the three data they used was in the coastline or estuary, but most of these animals are living in the sea. So how can they they estimate the rest between shoreline debris and the animal living, like the fish. The fish will never how to say, touch or contact the debris on the shoreline. But we all know that maybe the marine debris can move or wash back to the waters. So I think the author point out some bias in the 4.5. I mean, the last one of last limitations and the future directions. So I think my question is, there's still a gap between the density or distribution on the shoreline, and they want to use this data to estimate the risk of the animal living below the waters. So that is my idea.
Okay, thank you. Thank you, Jason. We have 4 minutes, 4 more minutes. We can discuss 1 or 2 aspects of this paper or others.
Not, we can wrap up the seminar and have a break for our next meeting.
If there is no opinions and questions, wrap up this seminar. Before wrap up seminar, I introduced a new person to Ocean, and his international person. Noel, please come here and say hello. And you.
We have to decide the date of the next seminar.
Okay.
Before that,
Thank you.
We will welcome.
I will not forget.
Noel,
Noel.
our new intern to Ocean. Introduce yourself.
Yes.
International Ocean. International intern.
Hello, everybody. My name is Noel. I'm from Switzerland, and I'll be doing an internship for 6 months here. Yeah, I studied environmental science, and yeah.
Okay. How long will you stay here?
6 months.
6 months.
Which university?
ETH in Zurich. ETH.
ETH.
Yes. Federal Institute of Technology.
We have one more intern in Ocean.
Hello everyone, nice to meet you. I'm Won-Yong Kwon and I'm intern for here for 2 months. Happy New Year.
What's his name again?
Won-Yong Kwon.
Won-Yong.
How about making English name? Okay. Let's decide next seminar the date and who will present the paper. 7th of February.
Yeah.
Okay, 7th of February.
Before I forget, Jong-soo, sorry, I just want to make sure this balloon, they found it on the beach or on the surface of the
beach data. Maybe they used the subtidal data because they suggested subtidal data by Smith and Edgar, but mostly beach data.
Wow.
Okay.
So is it mean that those balloon, when the high tide is not like goes to the ocean and go somewhere else, floating back?
Actually,
because the number is just enormous. I mean, it's crazy that how much they use.
Yeah, quite a large number of samples.
Like here, you know what they found here, Jerry? Opa?
What?
It's like 57 lighter to light the cigarette in
Yeah.
30 minutes. Clean up. 57 lighter. Like, can you imagine how many cigarette butt if you can find that lighter that much on one time clean up? Like, that's crazy. beside the ice bag, it's cigarette
Mm.
butt.
Well-
Okay, situations are different country by country, and I think we have to wrap up the seminar. It's already 11:30.